Long, long ago, and inconceivably far away, there was a universe. Newly born, it's a sphere of pure energy. It cooled and the first elementary particles formed. There were two types. They didn't play well together. The mixture was roughly 99.98% matter and only 0.02% antimatter. Cooling a little more, the strong nuclear force emerges, binding the quarks together. There is much more normal matter, so it takes over the role of space-time. This uses up almost all the normal matter, and now the mixture is only 0.05% matter and 99.95% antimatter. The little bit left over passes through the space-time because the attraction or repulsion from the space-time quarks comes equally from every direction. Matter has become unevenly distributed. This causes space-time to warp, attracting more matter, warping it further. As space-time warps, the strong nuclear force, aka gluons, binding the quarks weakens and bows outward and warps space. But at the same time, its quarks are squeezed together, no longer evenly spaced, and evenly applying their force. Grouped together, their forces now attract antimatter and repel matter. It's pure antimatter that converges on the space-time's compressed quarks. The antiquarks overwhelm and annihilate space-time's quarks. All the energy released trapped, the process sucking in space-time. The expanding energy is an ever-growing hole in space-time. Ultimately, the antiquarks run out, and the trapped energy stops growing and space-time stabilizes around the anti-energy, which is a sphere of pure energy. It cools, and when it does, we'll be back where we started. Oh, this stuff is interchangeable. But why does it cool? Back in space-time, most of the universe's matter has just vanished. Space-time can no longer see it, and its quarks are squeezed together, repelling each other and ready to explode apart. And they do, and the universe expands from the size of an atom to a lemon before reaching a new balance. It's what I had. And our new universe jumps to the size of an atom and starts to cool. What we've been looking at is one simple example. This happened everywhere in the universe, fracturing it like a glass sphere. Each place where space-time ejects a new universe, we've got a leftover concentration of matter. And, although its mass does not affect space-time, the concentration of antimatter still attracts space-time's normal quarks. This warps space-time and looks like gravity for no apparent reason. I guess someone could try to count how many new universes were spawned. Not me. In a black hole, time barely moves at all. So it is about 8 billion years later that the universe's expansion begins to accelerate as the universe welcomes its grandchildren. The universe expands and thins at an ever-accelerating rate as its offspring multiply. The trajectory of our universe's thinning matter is altered by her mother's thinning antimatter universe expanding around her, and so on and so forth. Energy trapped with nowhere to go, recycling happily ever after. This is Ron Williamson. Thank you for watching.